What is a wave? A wave is a disturbance that travels through a medium from one location to another. Waves only transport energy, not matter. In the case of the slinky's particles are only being temporarily displaced. It's the energy that's being transported from point A to point B. What is a particle? A particle is an interacting part of the medium that the wave travels through. What is light? Since light does all four of the wave phenomena, reflect, refract, diffract, and interfere, we believe that light is a wave, right? Wrong! Let's talk about this. What is a wave's energy determined by? If you were standing on the beach and lots of high frequency but low amplitude waves, aka ripples, were coming at you, would you fall over? No. But what if a high amplitude wave came at you? Would that make you fall over? Yes. So, what determined the energy for a wave? The frequency or the amplitude? If you guessed amplitude, you are totally right. A particle's energy is determined by its frequency. Let's say we have two types of bills, $1 bill and a $20 bill. Which one of these has more frequency? Or which one of these has more money per bill? The $20 bill. Energy is the capacity to change, and the $20 bill has more capacity to change than our $1 bill. Therefore, in a particle, its energy is determined by its frequency. So what does this have to do with light? When we increase the amplitude of a light, we make it get brighter. When we increase the frequency of a light, we change its color. So, if I want to increase the amplitude of a light, I would just have to increase its brightness. That way, it'll give off more energy and make more change, right? Wrong! Let's apply this principle to the photoelectric effect experiment and see how it works. First, we're going to get a rubber rod and rub it with fur. This puts electrons onto the rubber rod. Now we're going to transfer those electrons from the rod to the plate. This causes the plate to become negatively charged and the leaves repel. Now we're going to use a flashlight or visible light to try to excite the electrons off of the electroscope. Nothing happens. Now we're going to try a dim floodlight. Nothing happens, so we'll make it brighter. Still, nothing happens. It isn't until we try higher frequency light or ultraviolet light that we finally get something out of this experiment. In this case, higher frequency caused the electrons to jump off, or frequency determined the energy of our light. So what was light's energy determined by? Amplitude or frequency? Frequency! Was it acting like a wave or a particle? A particle! And there you have it! That was a photoelectric effect experiment that proved that light is actually made up of tiny little particles called photons.